Friends, this is part of your sample paper. In this video, we are going to discuss the engineering module questions. Okay, so this is the concept of buoyancy, which is discussed in this sample paper. So in your paper, you will have some basic knowledge of any concept, like the buoyancy concept is discussed here. You have to go through this concept, and most probably you know all these things. Let us go to the questions related to this buoyancy, and in the next video I will discuss some new questions similar to this one. In this video we are going to discuss only the sample questions which is available for your examination. Okay, let's see the first question. What is the relationship between buoyant force and the displaced volume and the density of the fluid? So we know the buoyant force is the weight of displaced liquid. Weight of displaced liquid or fluid. Basically, we should say fluid first. This is applicable in fluid. Fluid may be your liquid, maybe your gas, right? So weight of displaced fluid. So how we can write the weight? It should be written density of the liquid or fluid, density of the liquid, volume of displaced liquid into G. Basically, this density into volume gives you the mass of the displaced liquid. This will gives you the mass of displaced liquid, right? So this m into g is the weight. There is a little difference between weight and the mass. I hope you are getting this, the difference between weight and mass. So this is the mass, density into volume into g gives you the weight. We know the density. What is the density? Density is mass upon volume. So we can write mass should be equals to density into volume. That's the concept which is applied here. So this is the basic concept of Archimedes principle. What is the buoyant force? Buoyant force will be weight of the displaced fluid. It will act upward, right? So we have to find the correct relationship between the buoyant force, displaced volume, and the density of the fluid. Okay, let us see. The first one, the weight of the displaced fluid, the volume and the density of the object determine the density of the buoyant force. See, density of the object. This is not correct. Right? Let me zoom it. See what it is saying. The weight of the displaced fluid, the volume, and the density of the object determine the direction of the buoyant force. There are a lot of errors in this statement. So obviously this is wrong. The second one, the buoyant force decreases when the displaced volume of the fluid decreases, right? So what do you say? The buoyant force decreases when displaced volume of the fluid decreases. We cannot say directly on this statement that it is true. See, in the first go, you will see FV should be equals to density of the liquid, volume of the displaced liquid into this acceleration due to gravity. In the first go, in the first thinking, you can see if the volume of displaced liquid decreases, the buoyant force should decrease. But see, this is not always true. This is also dependent on the density of the liquid also. It may be sometimes that if volume displaced is less, but buoyant force may be greater, right? This statement may be true when it is given that density of the liquid is same like this. So buoyant force decreases when displaced volume of fluid decreases. I will not consider this one more correct. Let us see the next statement. If we find some better option, then I will select that option. Otherwise, I can select the B also. The buoyant force increases when the density of the object increases. See, again, if density, the buoyant force increases when the density of object, this is the wrong, not density of the object, it should be density of liquid, right? The last one, the buoyant force increases when the displaced volume and the density of the fluid increases. See, this seems more correct. The buoyant force increases when the displaced volume, this is the displaced volume, and the density of the fluid or the liquid. This is saying the fluid. As I told you, this is true for fluid, not only for liquid. So the density of the fluid increase, volume of the displaced fluid increase, buoyant force obviously increase. So I think D is the most appropriate option for this question. Let us see the next one. A can with a sugar containing drink. Let us represent graphically. So this is a can A. We can assume this is a can A and it contains the sugar containing drink. And a can with sweetener containing drink. Let's suppose we have another can. This is can B and in this we have sweetener containing are placed in a tub of water. So both are placed in tub of water. Okay. Both cans have the same volume and okay, so both cans have the same volume. It means the capacity of these cans are same. They have the same volume. Let us suppose the volume is V and are made up of same material and they are made of the same material. It means the density of this material is same. The sugar drink sinks, so it will sink at the bottom, and the can with sweetener containing drink swims, and the can B is swimming. Which statement regarding the mass of the can content is correct? So now we have to say we have to select correct option for the can content, right? Okay, the mass in the cans is the same. How we can say? See, first of all, please see. If you put these cans inside the water, what will be the buoyant force? So buoyant force should be equals to density of the liquid, volume of displaced liquid into acceleration due to gravity. Now, density of the liquid both will have the same because both are immersed in water. So density of the liquid will be same. Volume of displaced liquid. What is it? Volume of displaced liquid will also be same because both the cans have the same volume V. Both the cans have the same volume V. Let us suppose both the cans have the volume of 100 ml. Both the cans have volume of 100 ml. So the volume of displaced liquid will also be same and the G. So it means both have the same buoyant force. We can represent this FB on both the cans. But one can is one can is swimming and another can sinks. Why? So this indicates that the one in one case the weight is counterbalanced and in another case the weight is not counterbalanced. So the weight should be in downward direction mg and the weight here it should be mg. Both cans will have the different weight, right? In their weight they will include the weight of the can as well as the weight of their content, whatever they contain inside the can. So let us suppose for the can A, what will be the weight of this can? So it will include the weight of the can itself plus weight of the we can say drink, and in can A it is the sugar drink, so we can write it is the sugar drink. Now in can B if we see the can B, what should be the weight of this can B, the total weight? So it should be the weight of can itself, and it should be equals to the weight of can A, because they have the same material, same size, same volume. So obviously the weight and the mass will be same for both the cans. Now the another one will be the weight of sweetener, right? Right. And in one case it is counterbalanced, and in another case it is not counterbalanced. So in the first case, WC plus W sugar drink, since the can A gets sinked in the bottom, so it means this should be greater than FB, right? And for the can B, it is floating, so we can write WC plus W sweetener drink. It should be less than, or we can say equals to, should be equals to FB, right? Now compare. This quantity is greater than FB and this is equals to FB. And see, in this FB, we can replace with this one. So we can write, or we can think that weight of can plus weight of sugar drink should be greater than weight of can plus weight of sweetener drink, right? This now see, this is an inequality. So if you subtract WC both sides, they will cancel out. So now we are getting weight of sugar drink will be greater than weight of sweetener drink. Okay. Now weight is what? Mass into acceleration due to gravity. So we can write mass of sugar drink into acceleration due to gravity should be greater than mass of sweetener drink into acceleration due to gravity. This G and G can we cancel out? So we are getting mass of sugar drink will be greater than mass of sweetener drink. It means the mass of the drink in can A is greater than the mass in can B. So according to option, let us see. The mass in the can is the same. This is the wrong one. The can with a sweetener containing drink has a higher mass than the can with the sugar containing drink. No, this is the wrong. The mass of the can with the sugar containing drink is higher than the mass of the can with the sweetener containing drink. Yes, this is correct. Sinking and swing are independent of the mass of the cans. No. Okay. This depends on the mass of the can as well. It has to be compared with the buoyant force, the weight and the buoyant force. And the weight depends on the mass. So we cannot say that they are independent. Okay. Now let us see the next question. That is example number 3. I hope you are getting these questions. A wooden boat swims in a bucket of water. So we have a bucket of water and there is a boat which is swimming. Okay. Stone figure is put on the boat. So there is a stone figure. Remember, this is a stone figure. This is made of stone. Figure falls into the water and sinks to the bottom. Obviously, when it will fall, it will sink into the water. So this is the stone fall down inside the water. Okay. What happens to the water level? Now we have to discuss what will be the level of water in this bucket. This was the initial. This was the initial level. Now again, see, since this boat was floating with the stone, it means the total weight of this boat, that includes the stone as well, is counterbalanced by this FB, right? Okay, so let me write. So FB should be equals to density of the liquid into volume of displaced liquid into acceleration due to gravity. And this should be equals to the total weight of this boat should be equals to weight of boat plus weight of stone, right? And if, see, this is the first case. This is the first case. In the second case, when you throw the stone inside the water and only boat is floating, in that case, your FB dash should be equals to density of the liquid, volume of displaced liquid. We can represent it by V dash into acceleration due to gravity, and this will counterbalance the total weight will be the weight of boat only, not the stone, because stone is not inside the boat. Now, what will happen? See, See, basically, in the first case, you are counterbalancing a greater force. See, this is obviously a greater weight. So this buoyant force is counterbalancing greater force. See, density is same, acceleration due to gravity is same. So how it is possible to balance a a greater force, a larger force? So only this displaced volume will adjust this. It means in the first case, you are displacing more liquid or water. We can write volume of displaced liquid in the first is greater than volume of displaced liquid in the second part. See, this was the volume of displaced liquid in the second part. I hope you are getting right. So we are getting that in the first case, volume of the displaced liquid is greater. Now, if you are displacing more liquid, what will happen? Obviously, the displaced liquid will, take other volume. So the water level will get raised because you have displaced the volume of water. It will take some other space. So the level of water, will be high. But now here the case is opposite. In the final situation, I am displacing less liquid. In the final situation, after throwing the stone inside the bucket, now the boat is displacing lesser amount of water. So what will happen? So now the level of water will get decreased. I hope you have understood this. So water level remains the same because the water the water level remains same because the boat and the figure displays the same volume of water as before. The water level decreases because the figure only displays its own volume. This is the correct. The water level decrease because the figure only displaces its own volume. The next question is saying, why is buoyancy greater in salt water than in fresh water? So basically the buoyant force is Fv equals to density of the liquid, volume of the displaced liquid and acceleration due to gravity. The density of the salt water is greater, obviously, because they have the salt dissolved in it. So density of the salt water is greater. So what should be the answer? The density of salt water is greater than the density of fresh water. So this should be our answer. Let's see the next one. A submarine swims in water, right? There is a submarine. Okay. The volume of the submarine during surfacing and diving remains the same. It means the volume remains the same, right? During the surfacing or during the diving. For diving, the submarine must release air and be filled with water. Why? Because see, basically on this submarine, there will be some weight, mg, and there will be some buoyancy force. And see, suppose it wants to diving. So for diving, the mg should be greater. If mg is not greater, it remains, on the surfacing or in the floating condition. So for diving, mg should be greater. So how it can be possible? Volume is the same. You cannot replace, you cannot change the volume. If you change the volume of the submarine, submarine gets shrink inside, the space of this submarine gets reduced. This is not feasible, right? So what we can do, if you are not able to decrease the volume, it means you are not able to change the displaced liquid volume. It means you are not able to change the buoyant force. You cannot change the buoyant force in this case because you are not able to change the volume of displaced liquid. You are not able to change the volume of the display density of the liquid, right? So basically, we have only option to change our mg. And how we can change the mg, how we can change the total weight? If we put some water inside the submarine, if we take some water inside the submarine, then obviously its weight will increase. So for diving, the submarine must release air and be filled with water. That's why it is saying for diving, the air should be released and water should be taken in. Now we have some following data. The mass of the submarine is 14.2 tons. So mass is 14.2 tons. M is 14.2 tons. The volume of the submarine. So this volume of the submarine is 24 meter cube. The density of the liquid is 1 ton per meter cube. The acceleration due to gravity is g. So we have to find how much water should be taken to be going inside in the water or for the diving. Okay. So if you want to go inside the water, if you want to if you want to be diving, it means FB should be less than mg, right? And FV should be what? FV should be density of the liquid into volume of displaced liquid into acceleration due to gravity should be less than mass into acceleration due to gravity. Density of the liquid is 1 ton per meter cube. Density is given, volume is given. This is 24 meter cube. See, density of the submarine remains same. It will displace this much of water always. And this is the G. It should be less than mass. What should be the mass? It means mass of the submarine, that is 14.2 tons, should be 14.2 tons plus mass of some water. We don't know how much mass of the water should be taken, so that it gives you this result. G and G can be cancelled out, meter cube can be cancelled out. So we are getting 24 should be less than 14.2 plus mw, that is the mass of water. All masses are in tons. So for mw, we can find it should be resolved in this way. It should be 24 minus 14.2 mw. Mw should be greater than this. So if you do 24 minus 14.2, what you will get? 24 minus 14.2 will get 9.8. It means mw should be greater than 9.8. mw should be greater than 9.8 tons, right? Let us see the option. So according to first option, this may be possible. Yes, 14.2 tons is greater. Option number B, 10 tons, it may be possible. Option number C, 24 tons, it is also possible. And option number D, 9.8 tons, it will not possible because I want greater than 9.8. Question is saying how much water must fill the salmon so that the salmon can dive. So since all the three options are correct, we have to find the minimum one, the minimum possibility. So the first option, which is just greater than 9.8, that is the 10 tons, it should be its answer. So answer should be B, that is the 10 tons. I hope you are getting the explanation. In the next video, I will share some good questions based on similar approach and similar concept. So if you like this discussion, please like this video, share to your friends and subscribe this channel. Thank you. Thanks for watching.